Hello, everyone. I have the opportunity today to talk to Dr. Patrick Moore. I'd been following Dr. Moore for quite a long time, and I had the privilege of hearing him live in a little meeting on Vancouver Island here recently, and we decided to do a podcast together. Dr. Moore is in the interesting position of being skeptical, to say the least, and unconvinced of the doomsaying prognostications of the climate apocalypse mongers, but also have been active in the environmentalist movement for 50 years. He was one of the founding members of Greenpeace back when they were working primarily on anti-nuclear campaigns and on campaigns to protect the remaining whales in the tragedy of the Commons oceans against overfishing. Dr. Moore became convinced that the environmentalist organizations as such were in the process of being taken over by actors whose primary interest was not the green movement in the environmental sense or the peace that Greenpeace once stood for, but more the promotion of a kind of radical self-interest combined with the hysterical doom-mongering that's now typical of the apocalypse promoters. And so we go through the evidence of climate change and environmental composition over about a 500 million year period, concentrating particularly on the last 2 million years, and present the hypothetically appropriate conclusions in that climate denialism festival. So join us. Well, hello, Dr. Moore. Thank you very much for agreeing to talk to me and to everybody else on this platform today. We met recently in Vancouver Island. It was the first time I'd heard you speak publicly, and I was very interested in the story you walked through. And so I thought today we could start with your adventures, your early adventures with Greenpeace and what you were hoping for from that environmentalist organization, and move from that to your divergences with their current worldview, let's say, and the reason that divergence was necessary and right. So let's start with Greenpeace. Let's begin with that.
Well, Jordan, I was doing my PhD in ecology at the University of British Columbia. I had excelled in the life sciences all through high school and in my undergraduate years, mainly interested in evolutionary biology, photosynthesis, ecology in general. And I was radicalized by the Vietnam War, the threat of all-out nuclear war, and the concern for the environment, which was a new thing. The word ecology had not yet been used in the popular press. It was an obscure scientific term. And I think I was the first PhD ecologist to graduate in Canada. As far as I don't know of any others. And so I learned through a little piece in the newspaper that a small group of people were beginning to meet in the basement of the Unitarian Church, which is a church that accepts all religions. And not that I'm particularly religious, but I agree with that sort of thing of peace and an end to warring and all of that sort of thing. I'm a pacifist, I guess you could say. But I'm also fantastically interested in nature and the evolution of life from no life to life. I think there's two things that we can probably be sure we will never know the answer to. One of them is, how did life begin? And the other one, is there anyone else in this universe besides us? It hasn't become apparent to date. And we've got all kinds of listening devices and we're a young star. The sun is a young star. So many of the stars that would have planets around them that are billions of years older than our star, you'd think if life was going to happen on them, it might have done so by now. So those are kind of my basic philosophies, where I think there are things that we can never know. Many of them, probably, maybe some that we don't even know how to speak about. But ecology, the science of how all living things are interrelated, not only with other living things, but also with the planet as a whole, and even the solar system, because Saturn has an effect on tides, and it has an effect on these cycles of glaciation and interglacial periods that have been going on for 2.6 million years during the Pleistocene Ice Age. So that's how I see the world, as everything being interconnected. And that brings me to, well, what is really the fundamental meaning of science and scientific discovery? Because science is about discovery primarily. And I have three steps that describe the scientific method. The first one being observation. And if you can't observe something either with your own senses or with the machines we've made, like X-ray machines and all the other things we have that we can see inside people, we can have radiation detectors and all that sort of thing. So they're part of our ability to observe what's going on in nature or in the world and in the outer world. So that's what's needed, is first observation, and then second comes verification, where you've observed something, and then you see if it repeats itself over and over again by very carefully trying to prevent outside forces from interfering with the two things you're looking at, where you think there might be a cause and an effect relationship. And that's mostly what science is about, is discovering cause effect. And so you do that yourself to make sure that when you tell other people what you think you've found, you'll be on solid ground. And then there is replication, where other people see if they can do what you did. And if they can, especially if it's 100% kind of thing, then you have a theory, a scientific theory. And the reason that most of the scare stories today are about things that are either invisible, like CO2, radiation, and the bad thing that's supposed to be in GMOs, which doesn't have a name. Everything has a name. So if it doesn't have a name, it doesn't exist. And that's my opinion on the subject, is there's nothing in GMOs that is harmful. Otherwise, it would probably harm people. And many people are eating them by the millions. So that's just a total hoax, as much as the climate emergency, or climate crisis, as they like to call it, is a total hoax, because people cannot see what carbon dioxide is doing. They cannot do the first thing in science, which is observation. And therefore, for some reason, the sort of mass hysteria effect takes place around many subjects. And so it's not just things that are invisible, though. It's also things that are so remote that no one hardly can go and look at it for themselves. And I use the two examples of polar bears and coral reefs. Very opposite. One's in the hottest tropics, the other's in the coldest Arctic. But and hardly anybody gets to see them. I mean, I've been lucky. I'm a diver and a snorkeler, and I've been to Indonesia on 3 2-week trips to all the coral reefs there, which is the richest in the world. Happens to be also the warmest ocean in the world. And yet people can't see for themselves, when they heard in early 2016 that 93% of the Great Barrier Reef was dying, or terminal, or in its final terminal stage, as if there were other terminal stages before the final one. And you notice they never said dead. They said dying, terminal, or, also bleached. They love to use that word. Whereas bleached isn't like bleach that you make clothes white with. Bleach means they've ejected their phytoplankton, and they're a symbiotic relationship between a polyp, which is an animal related to jellyfish, which is in the little holes in the coral, the tiny trillions of them in a very small area. And then the phytoplankton are taken in by the polyps and put under their skin, which is translucent. And so they can still photosynthesize in there and give some of their sugar to the polyp, and the polyp gives them protection from predation. So it's a perfect example. But the point is, last year, in the middle of the summer, it was announced by the whole group of people who are studying the Great Barrier Reef that in the 36 years since they've been doing it, thoroughly, it was the highest coral cover yet known. So weigh those things. It's 93% dying. Oh, no, sorry. It's got more cover than it ever has in the last 36 years. And that gets in some tiny amount of media, whereas the other one went worldwide that it was dying. And the thing is that the highest biodiversity of all coral reefs is in the warmest ocean in the world, which is Indonesia. It's protected from the north by Asia, and it's protected from the south by Australia to cold water incursions that come into the Great Barrier Reef and many others. But they say if it gets warmer, the corals will die. No, they will spread, because we're coming out right now of a period when the Earth was so much warmer. The Eocene thermal maximum was happened 15 million years after the dinosaur extinction, which was almost certainly caused by that asteroid that hit Yucatan and sent ash into the stratosphere, where it blocked the sun and caused plants to die and mass extinctions to occur. And if the planet warms from what it is now, which is actually one of the coldest periods in the history of the Earth, this is the great irony. Now I'll try and go just quickly into the three most important points about climate change. One is that this is one of the coldest periods in the history of the Earth. That's why the huge ice caps are covering both the North and South poles. There were forests in the South Pole, and there was no ice in the Arctic until about 3 million years ago. Since 250 million years before that, when the Karoo Ice Age, which lasted 100 million years, the same sort of thing we're in now, where the poles are all covered in big sheets of ice. Since 250 million years ago, when it ended, the Earth has been warmer than it is now.
So you're focusing on time frame, and this is something that's perplexed me continually with regards to both the climate debate and the carbon dioxide debate, because my sense is that you can derive whatever conclusion you want, essentially, about temperature and about carbon dioxide and about the relationship between temperature and carbon dioxide by merely arbitrarily choosing a particular period of time to study. Now, what struck me about the presentation of yours that I saw was that you circumvented that to some degree by using extremely long spans of time. And so the claim that you just made, let me just lay it out again for everyone who's watching and listening, is that over the last 250 million years, we've rarely been in a period that's as cold as it is now. And that for much of that time, when there was no shortage, we never have been. Okay, we never have been. Now, there have been periods of time in the Earth's history when the whole Earth was an ice ball. How long ago were those periods of time?
2 billion years ago. It's theoretical. It isn't proven. It is possible that there were ice ages that were more extreme than the three that have occurred in the last 500 million years. The Silurian was a shorter ice age that occurred when CO2 was at 6,000 parts per million. You know, it's 400 and some now, and they're saying it's going to make the Earth go on fire. And then the Karoo was 100 million years long. That was during the time when forests evolved. And it was very similar in temperature to the one we're in now. You see, the International Stratigraphy Institution, I think that's not quite its name, but stratigraphy is the layers of the Earth that you can read the ages and the fossils and stuff like that. They have declared this Holocene interglacial period as a new epoch. The Pleistocene is an epoch, and it's lasted for 2.5 million years, and there have been at least 40 interglacial periods, no different from this one, during that time. None of them are called epoch.
Okay, that's a span of how long did you say, the Pleistocene?
2.6 million years it's arbitrary, but it was going down, and they said, okay, this is where we'll call it the Pleistocene. because it had become so much colder than it was 50 million years ago. And it had gone down quickly, and then it leveled off for a while, for about another 10 million years. And then it crashed down to where we are now, with the fact that we are in as cold a period as has ever existed in the past 550 million years. Now, as for iceball Earth, iceball Earth is too long ago to have accurate records. There's all kinds of. I've read a lot about it, and there's a lot of speculation involved in it. Obviously, the world didn't freeze over completely, or there wouldn't be any life here again. I mean, life had already occupied all the oceans of the world by that time, and there was no life to speak of on land. I'm not sure about bacterial forms. I mean, there's so much we don't know. The reason I don't go back, except to say that photosynthesis and sexual reproduction both evolved during that earlier period, going back 2-3 billion years. But multicellular life never came into existence until about 560 million years ago. Before that, every living thing had been unicellular, microscopic, and confined to the sea. So that to me, that's where we start. Really,
okay. So let's get all right. So let's get the biggest picture here and zoom in a little bit. So 4.5 billion years ago, we have the emergence of the Earth. We have the emergence of life. 3.5 billion years ago, and we have something like that. We have an unbelievably long span of essentially 3 billion years. Then, when life is unicellular. 500 million years ago, we get the emergence of multicellular life, and that's the time when you start to focus in on the data, thinking that, at least in part, the evidence for anything that happened before that is thin and speculative. How good is the evidence for our conception of climate and atmospheric composition from 550 million years ago to now? And also, from what sources is that evidence derived? Like, how do we know what the temperature was? How do we know how much carbon dioxide there was in the atmosphere across that 500 million year period? And how much more accurate do our estimates get as the millions of years progress?
Very good question. Yes, we have a lot of proxies. The best evidence started to occur in 1958 in the International Geophysical Year, when ships went out all over the world and drilled deeply into the marine sediments to look at various proxies. Oxygen-18 is a really important one. It has to do with different decay rates of different isotopes of various elements. I'm not an expert on this, but I know that's how it's done. Also, the foraminifera, which are a tiny shelled animal that lives in the sea and is of huge abundance. We know from the shape of their shells how long ago it was, along with the proxy radiation stuff. So we can look deep down into these sediments and see the evolution of life. And the first multicellular life was pretty well all just like jellyfish. There were no shells yet or bones. And the clam family went off to make a shell as like a knight in armor, like a protective plating around its whole body, and made it much less susceptible to predation. But the bony fish decided to have, then they started from way, way back, that same sort of 500 million year period. And the skeleton and the central spine became a very desirable thing to have, to hold the fleshy part together. And
academics could learn from that, Patrick, I would say. The importance of a spine, you might say.
Yes, quite important. But you'll find that everything that has a spine can run pretty fast because we don't have a shell around us. Whereas the the bivalves and univalves and all of the other shelled species in the sea in particular, there are freshwater clams and mussels, which is proof that the oceans won't become so acidic, as they like to say, less alkaline is what they really mean, that it's going to melt all the shells of the shelled creatures in the sea. That's ocean acidification. I have a paper on it called basically a relook at this idea, because it only emerged. The whole idea of ocean acidification emerged when the temperature stopped rising in the late 90s. There was a flattening out period, and everybody's going, "Oh no, we have to create a new scare story because this one isn't working as well as it used to." And that's the kind of thing that drives a person like me nuts, because they get away with this.
Yeah.
And so the shelled creatures, though, can be what's the word for stay in one place? Sedentary. Yes, and they can be like oysters and all those shelled species, but the jellyfish are still around, but most of them have stingers. So they don't have to be able to run away too fast, because the other species know that it's not a very pleasant experience to swallow one. And so all these different strains, the phylum of life, many phylum have emerged in this 500 million year period. And the only reason they're still here is because they were successful. Now, people say that when I say, well, the Eocene thermal maximum was like way hotter than it is now. There was no ice anywhere for 250 million years, and life thrived. The dinosaurs thrived. If it hadn't been for the asteroid, they'd still be here. But it made room for us mammals to fill the gap. And so they say, but humans couldn't have lived through that. No, but their ancestors did. If we wouldn't be here if our ancestors hadn't lived through the hot period. And so that this 500 million years gives you absolute proof that the climate emergency and this strong relationship between CO2 and temperature, they are out of sync through that 500 million year period more than they're in sync. And that proves it is not a cause-effect relationship.
Okay, so let's review this. So far, we've established that we have reasonable records of climate and atmosphere for a 500 million year period, let's say. And we've derived that in part from the study of radioactive isotopes and partly from the study of the shells of shelled animals that have been around for an extraordinarily long period of time. And so we can get a pretty decent picture of both climate and atmospheric composition during that period of time. And what we see is that for much of that period of time, in fact, for all of it, in your estimation, the planet was in fact much warmer than it is now, to the point where there was no ice for most of that period of time on either pole. Yet during that period, life flourished abundantly. Also during that period, this 500 million year period, for almost all of that time, there not only was more carbon dioxide in the atmosphere than there is now, there was way more, 5 times more, 10 times more. And the consequence of that was that plants flourished. Also, the carbon dioxide and the temperature during that period are radically out of sync and not obviously causally related. Is that a good summary of the 500 million year evidence? So
indeed it is.
Okay.
Well, I just say that the Karoo Ice Age lasted 100 million years. The Silurian only lasted for about 10 million years. Ours is only 2.5 million years, and they're declaring it over without any evidence whatsoever that it's anything like over. As a matter of fact, of the 40 interglacial periods that have occurred, the most recent ones have shown a continuing decline in the warmth of the warm periods, which are the short periods. It takes 85,000 years to sink from where we are now back to the next major glaciation. See, they call it the last ice age, the one that occurred 20,000 years ago. No, it was the most recent glacial maximum, of which there have been 40 during the Pleistocene ice age. And the amazing thing is that the cycles that are occurring here are asynchronous. Like for the first 1.5 million years, it was a 40,000 year cycle, in keeping with the shape of the Earth's orbit, which is affected by by Jupiter's gravitational field. Jupiter affects both our circle around the. It's not a circle; it's an oval, but it changes shape in tune with Jupiter's gravitational effect as it goes around the sun, and then the tilt of the Earth is affected by Jupiter's gravitational effect, and so is the wobble. The North Star won't always be the North Star because the tilt wobbles like this in a 20,000 year cycle.
Right.
I'm using round numbers. It's like 21 or something. But so this period we've had now for the last 2.5 million years, the graph shows very clearly from ocean sediment analysis that it's still getting colder in the cold periods.
Okay, so that's the Pleistocene, that last 2.5 million years. And that's the time that's been characterized by 40 precessions of ice.
Yes.
The last of which was the last ice age.
No, the most recent recent glaciation. The ice age is the Pleistocene.
Oh, yes, sorry. Yes.
But people, you've got that in your head because they're pouring it into you every day that it was the last ice age. When this is the last ice age, it's called the Pleistocene. It's the most recent ice age, but we also have these glacial maximums occurring, and so this is called the Pleistocene conundrum because no one knows quite exactly how that happened.
Okay, so let me rephrase that. So 2.5 million year period, which in totality is an ice age that's characterized by the movement and the movement forward and the recession of the ice masses. And the last major movement forward was 20,000 years ago, but we're still and now we're at the tail end of the recession. Where are we in that process?
No, we're at the tail end of the interglacial period. If it's anything like pretty well all of the previous ones, it really only lasts about 10,000 years. And the first part of it is warmer than it is. See, people are not even willing to look at 10,000 years. They want to say from 1850, right?
Yeah.
That's when the industrial era began. And now it's the industrial era that is causing this slight change in global temperature, when in fact this change started more like in 1600. That was the peak of the Little Ice Age, as it was called. And it wasn't an ice age either. It was just a cold period during an interglacial period, during a warm period. So, but the Little Ice Age was the coldest it's been since about 10,000 years ago, as it was coming up out of the real glacial maximum. They can't tell right at the beginning exactly how many there were and where you really start and all that stuff. But it's in the neighborhood of 40 glacial maximums, first on 100,000 year cycles, sudden switch to 40,000 year cycles, both of which tie in with the Jupiter gravitational theory. This was discovered in the 1920s, but they didn't have the detail that we have today. The fact is what I call it is the most recent glacial maximum was 20,000 years ago. They call it the last because last can also mean final, as well as most recent, right? So most recent is much more accurate than final. I don't know why final would be used unless they thought it was the last one. And there's absolutely no evidence for that because we've already started about 6,000 years ago going downwards slowly till we came to the Little Ice Age. And it was only 400 and some years ago that happened. People starved in the northern parts of Europe because it was too cold to grow food. And it doesn't take that much temperature. A couple 3 degrees Celsius makes the area where you can grow food move quite a bit. Just like in the glacial maximums, there was a mile of ice over and 2 miles of ice and 3 miles of ice. And around Churchill, like 4 miles of ice on top of the land. And there was almost nowhere in Canada that wasn't completely glaciated. A few places where there's very little precipitation in the Alaska area, Yukon area. But basically, the whole country was covered in a massive sheet of ice, which went way down into the northern tier US states. New York had a mile of ice on it. So, and that was only 20,000 years ago. And that had occurred time after time after time for 2.5 million years. And again, there is absolutely no indication that the Pleistocene is anywhere near coming to an end. Everything points to it getting colder or staying the same. Maybe the chance of it going back up is 5% if you look at the evidence as it presents itself.
Okay, so if we look at the last 2.5 million years, we're in an age that's cold enough to frequently have the progression of the glaciers. And that's happened, and they've receded 40 times. Now, you made allusion to some of the forces that are multiple forces that are causing that. You talked about the tilt of the Earth's orbit and what would you say, the irregularities in that tilt. So that's a source of variability. You talked about
if the Earth points more towards the sun, then the solar radiation goes further north and further south in our winter, their summer. So it can, that seems to be where it was triggered, was by these, the cycles fit perfectly. So you sort of have to go, well, that looks like it's a cause-effect relationship.
Right.
And it's happened so many times.
And you said the wobble itself is affected by even more distal forces like the gravitational pull of Jupiter. So there's many, many forces at play that are determining these large-scale cycles of climate over tens of thousands of year periods. And you don't believe that there's any evidence whatsoever.
There are cycles upon cycles upon cycles upon cycles.
Right, and you don't believe that carbon dioxide production per se is one of the major. Okay, so let's drill into that because I'm going to do everything I can to push back against you to evaluate that argument, because we want to give the devil his due. So I could say, all right. So the first thing I might say is, well, you could be right in that there's been a tremendous amount of variation across large spans of time, but the rate of change at the moment since 1850 is sufficient so that those perturbations will be hard for natural systems to adapt to, and they threaten the stability of the cultures that we've generated, predicated as they are on a particular, what would you say, manifestation of weather and climate. And so the right span of time is a 200-year period and not these tens of thousands of years or millions of years even that you're insisting upon. So how would you respond to that objection?
Well, John Clauser, who got the Nobel Prize in Physics in 22 or 3, has just joined the CO2 Coalition, of which I'm a founding director. And we're a group that only accepts people that we want to come in. You can't just pay money and be a member. We know what we're talking about. We've got some of the top atmospheric scientists and et cetera in the world as our group. And we're also associated with Clintel in Europe, which is a Climate International Alliance, I believe it stands for. And we're pretty much on the same page because it's the only page that makes any sense. The fact is, and John Clauser said it this way: the difference between the temperature 200 years ago and the temperature now, and you going to this 1.5 degrees and the Earth is going to burn up or whatever. That's less than between breakfast and lunch everywhere in the world. 1.5 degrees Celsius. It is so stupidly ridiculous to say that a 1.5 degrees Celsius increase in global atmospheric temperature is going to be a disaster. As a matter of fact, it will open up vast areas of farmland that were too cold before. A lot of this, I live in Comox, where I'm just barely halfway to the North Pole, and it's too cold for things to grow, for large parts of the year. And it would be nice if it was warmer. And the other thing that not many people know is that when the Earth warms, say back in the day, this is many millions of years ago when it was much warmer than it is now, it does so more towards the poles. The equator doesn't change. It's a constant that, like, the poles actually became subtropical during some of the interglacial periods before the ice age came. The ice didn't start building up in Antarctica until about 30 million years ago. And the ice didn't start building up in the Arctic until about 5 million years ago. The South Pole is always colder than the North Pole. The Southern Hemisphere is colder because it's mostly ocean. And it takes a lot more energy to heat up the oceans than it does to heat up the land. You're only heating up a little bit like this, but the oceans are like the atmosphere, are in cycle. They're in lots of different cycles, exchanges. So they're moving heat all over the place. Whereas the land doesn't move heat; it just absorbs it. And so the northern hemisphere has always been colder than the southern. Well, since the land masses were reasonably in the same place they are now, of course, over the hundreds of millions of years, the tectonic plates have moved around quite a bit. And at one time, they were all in one continent, with all the rest of the world being ocean. Gondwana, I think that's what that was.
Mm-hmm, mm-hmm.
And so the flows of heat. But the point is that in the Eocene thermal maximum, the temperature was at least 5 to 7 degrees Celsius warmer than it is now, maybe even more. And
how long ago was
the tropics? There were 50 million years ago was the peak of the Eocene thermal maximum, as it's called. And coming out of the glacial, coming out of the dinosaur extinction, there were 15 million years where it still was going up. It had gone down about halfway to where it is now in the middle of this 250 million year period, but it was nowhere near cold enough for any ice to be on the Earth. And at the same time, CO2 was going in the exact opposite direction than the whole of the temperature was. And that you can see that in the graphs, that there is no clear relationship. But the thing about CO2 is actually it is a greenhouse gas, but clouds are so much more important. Water is the most interesting one because as a gas,
they're not properly modeled. I also understand that in the climate models don't have sufficient resolution to appropriately model the clouds. And so you talked about 1.5 degrees, and that number has always bothered me because I understand, if I'm correct, that that's within the error margin of the estimates of the forcing effect of water vapor. I understand that it's a small enough measurement so that we can't determine if it can be validly detected in terms of an increase given our inability to model the effects of clouds. I understand that we don't have temperature measurements from terrestrial weather stations that are sufficiently reliable over even a period of several hundred years to ensure that our estimates are accurate within 1.5 degrees. I mean, I learned this not least by reading Michael Crichton about 20 years ago when he wrote one of the first exposés on the climate scam, pointing out that most of our terrestrial weather stations were placed in outside of cities to begin with, but that they've been the subject of encroachment by the urban heat islands since, and that in consequence, their temperature estimates have to be corrected for that encroachment, and there's error in that measurement as well. So
yes, and not only that, they're playing with the numbers. They're making it seem colder before they're actually NOAA, the National Oceanic and Atmospheric Administration, is actually they're lying. They're saying, oh, there's a good reason to show that it was hotter now and colder then, and then they change the numbers, and they're doing it without telling anybody, and then the graphs go out. I mean, this whole thing is so corrupt, and it's basically the problem is that politicians who work by scaring people that if this happens, you vote for me and I'll make sure this doesn't happen. But they quietly get their bureaucrats to give billions of money to scientists in universities who know that if they don't go along with the story, they're going to get fired. Never mind. They actually cannot counter this without being shunned. And if you've seen what's happened recently with the big universities and the kind of horrible stuff coming out from these people, not just on climate, but on social issues and war and all that sort of stuff. And I don't talk about that too much.
Yeah.
But I follow it. I follow it very closely. And there's all these scientists publish all these papers with doom and gloom as the main theme. You don't see the big corporations doing that sort of stuff. They're trying to make things that are useful. And now they're being forced into this electric vehicle thing. You know that using fossil fuels to make electricity is only 35 to 40% efficient. And then you're going to use that electricity to run your car. And it's only so efficient. I mean, it's more efficient than burning fossil fuels, but you're burning fossil fuels. 65% of all the electricity in the United States is still bought by fossil fuels. And they're pretending that doesn't have any CO2 emissions because the cars don't.
Okay, so let's turn our attention momentarily to the CO2 issue. So I became aware 6 or 7 years ago of the global greening phenomenon. So now we've been told for 60 years that as the carbon dioxide rates increase and the temperatures inexorably rise, that what will inevitably happen is that the semi-arid areas will turn arid and the deserts will expand. But what's actually happened, and
the opposite.
Not just the opposite in a little way, the opposite in an absolutely mind-blowing and unequivocal way, which is what's happened is that because we're actually in a carbon dioxide drought, which is also what your data point to, we're down to about 430 parts per million and plants start to die at 150 parts per million. The plants are literally metaphorically gasping for breath. And so they have their stomata open too wide, and that means they lose a lot of water. And that means that the semi-arid areas in the earth are wider than they should be, larger than they could be. So now carbon dioxide levels have gone up, and not even that much. And the consequence of that is that the plants are thriving in comparison. And this has happened over only a 20-year period. And so the amount of the earth that's greened since the year 2000 is equivalent to the total land area of the United States, right? Not only that, there's been a marked improvement in crop production. It's like 13 to 15%. So not only is the planet not desertifying, it's doing the opposite. And near the deserts, right, in semi-arid areas, plus instead of that being a threat to food production, it's actually enhanced food production worldwide. So my sense is that if we weren't ideologically addled and we were looking just at the straight data with the eyes of, let's say, new investigators, we'd look at the release of carbon dioxide, of the plant-based carbon dioxide sequestration from the fossil fuel reservoirs as the return of a necessary nutrient to the atmosphere, and we would consider it a net positive. And so what do you think about that? Is that, like, I just can't draw any other conclusion. When I found out that the area of green on the planet had expanded that much in 20 years, I didn't know what to think of that, because not only does it indicate that the desertification by carbon dioxide hypothesis is erroneous, it's actually the opposite of that. It's literally an anti-truth, the notion that carbon dioxide will cause desertification. And it seems to me that environmentally oriented people should be thrilled that the planet has become substantially greener and that agricultural land is more productive, because it means we'd have to use less of it. So, I've gone so far as to delude myself into thinking that adding carbon dioxide to the atmosphere is one of the most effective ways we can possibly distribute fertilizer. So given that we need to burn fossil fuels for all sorts of other reasons. And so that's so far away from the current narrative that it seems like a delusion. So what do you think of that? What do you make of that?
You studied well. Yes, all of what you said is absolutely true. And many of us, like you and I, know about this, and it falls on deaf ears for some reason. And I go back to burning witches and throwing virgins into volcanoes. People did these things, and the rest of the people accepted it or even supported it. And so what is it, some kind of collective death wish? Because the fact is, during the most recent glacial maximum, as I like to call it, 20,000 years ago, CO2 sank to 180 ppm in the atmosphere. That's because when the oceans cool, they absorb more CO2. And when they warm, they outgas CO2. I use the example of taking a glass of cold water out of the fridge and putting it on your counter. In a few minutes, bubbles begin to form on the glass inside. That's the gas coming out of the water. Put it back in the fridge, they disappear. So Henry's law is an actual scientific formula that determines the equilibrium between CO2 in the water and in the atmosphere. And given that the water is 70% of the land's area, this is a fairly major factor in things. And so it went down to 180. And as you know, at 150, plants die, right? So it is thought that many of the high elevation plants did die for lack of CO2, because as you go up, the air thins out. So 150 parts per million becomes a lower number as you go up.
Yeah.
And so because there's ash deposits at those altitudes that seem to be like pervasive. And I think that's a logical conclusion. I mean, in other words, it's not a bad hypothesis because it was so low, and so I say that human emissions of CO2 are a salvation, not a destructive tragedy or an emergency or a crisis. It is actually that this species, has not only figured out how to build airplanes and spaceships and computers, but we have also reversed the continuous downward trend for the last 500 million years, with a few blips up and down in between. But for the last, say, 150 million years, it's been a steady downward line. Starting
with regards to carbon dioxide percentage.
From 2,500 ppm 150 million years ago to 180 20,000 years ago. And when we came out of that most recent glaciation, took about 10,000 years to get up to what's called the Holocene climate optimum. Because the first 5,000 years of the Holocene were warmer than it is now. The Sahara was green. CO2 was a little bit higher. It went up to about 280 after the 180. The warming of the oceans caused outgassing and made it 280 by the time industry began. And then industry has taken it from 280 to 425 or 6 or something right now. And it just keeps getting greener. But the Sahara's not green yet.
Right.
Because it isn't as warm yet.
I've read that it's shrinking on its southern expanse.
Yes, it is. But the fact is, there are red dots on maps showing all the villages that were all across the Sahara Desert with goat herders and sheep and stuff, like back then for thousands of years. And one of the reasons they say the Egyptian civilization began was they all had to move into the Nile Valley because it was the only place where there was enough water to live. And the Sahara became a desert 6,000 years ago. Or 5,000, something like that. But anyways, that's the time when everybody had to move, and that created one of the first big urban centers, along with the Middle East.
Okay, so let me extend the criticism of the current climate apocalypse mongering on a different ground, and then let's let's investigate for a brief period of time why this story might be making itself manifest. You already pointed to some degree to the corruption of the scientific enterprise, but that's not the whole story. So my license in Canada to practice is being threatened, right, by my professional board. And one of the reasons for that, by the way, is that some random complainant in the United States, who I never had any professional dealings with whatsoever, like all the people who complained about me, by the way, submitted the entire transcript of a Joe Rogan interview that I did on where I discussed climate in some of the same ways that we're discussing it. And one of the things I pointed out was that the models that we use are radically dependent on a set of initial presuppositions. They're not very accurate in their estimates of such things as terrestrial temperature. They don't model water vapor well or clouds. And so they're not data, they're models. And so they're not reliable. And then they are fueled in their development by the people who want the apocalypse mongering to continue. So that makes me very skeptical of them. But then there's something even worse. They use those models to generate a 100-year prognostication, which is a long way out there. And that means the farther you go out with your models, the more the errors multiply. But then they stack an economic model on top of that and claim that the consequence of the 1.5 degree elevation in temperature is computable economically 1 century from now, and that the consequences will be devastating. Well, I read all of Bjorn Lomborg's careful work, and Bjorn has accepted the IOCC prognostications about temperature increase, and he's calculated what that's likely to cost us in relationship to the fact that our economies continue to grow and that people are flourishing. And his conclusion is that not only is there no climate apocalypse, because that's a complete bloody lie in the way that you just described, but there's also no economic apocalypse, even if the climate scientists are right, because our proclivity to become more productive will radically overwhelm the slight detrimental effect of any climate transformation. And so, anyways, for stating all that, that's part of the reason that my license as a clinical psychologist is being threatened, which is, sort of an indication of the current state of the world. And so I don't know if you have anything to say about the economic models, or if we should just leave that lie. And so what do you think of that line of reasoning?
Economics is sort of in the middle of real hard science, and I don't know, naturopathy or something. Right. Not that I don't agree with a lot of naturopathy, but it's soft versus hard science type thing. And it's just so insane that they are doing this, because the IPCC itself, the Intergovernmental Panel on Climate Change, part of the United Nations apparatus. It's partly the Meteorological Association and the Environmental Center in Nairobi. And they're very political, of course, but twice during the publication of their large volume, they have a public one for the public, but they also have a big volume that they put out every 4 years. And twice they have said, to effect, it is impossible to determine future climate trends. You see, chaos, the very definition of chaos is that you can't see through it. I've been a boater all my life and built a few of them too. And I love the bow wave because at a certain speed, you're going slow, and it's a beautiful laminar flow around the bow. There's no turbulence. And then you get going a little faster, it becomes turbulent and frothy. It's impossible to predict where each of the atoms are in that chaotic system. And that's the same thing as the climate. There's no possibility that anybody can predict the future with a computer. Especially, you can predict some things with a computer if you've got a perfectly linear thing that you're looking at.
Yeah.
But you can't predict something as complicated as the global climate. Another point I'd like to make is that, people are saying that it's going to get too hot to live on the Earth. We are a tropical species. We're not polar bears. That's why we're not covered in massive fur coats, because we evolved at the equator, and we stayed there for a very, very long time and couldn't come out of there. Even my place here in Baja on the Tropic of Cancer is too cold for people if they don't have shelter and fire. So I believe that the control of fire was the beginning of the species called humans. And that it went from there to clothing and needles for knitting hides together, and then nice houses and with nice fireplaces and lots of wood around. And, one of the reasons the forest fires are so bad in the western US is they don't clean the wood off the ground, and they let trees die and just stand there. Back in the day, before there was any fossil fuels, every village, every tribe, every town, every city, they collected all the dead wood for miles around their dwelling places and used it for their firewood in the winter because it was dry already and easy to get because it was already on the ground.
Right.
And so people don't recognize that. And you got to manage a forest properly if you don't want it to turn into a conflagration like they have done in California and many of the other Western states. But back to clouds. Joni Mitchell, I've looked at clouds from both sides now, from up and down, and still somehow it's clouds' illusions. I recall we really don't know clouds at all. She said one of the most prophetic scientific things of any modern singer. And this is true. We cannot predict the clouds. And they have multiple forces. They reflect sunlight off the top. They keep the Earth's heat in at the bottom. They rain all over the place and make everything wet. And then you've got the fact that H2O, name me another compound that has all three states, gas, liquid, and solid. The ice has a huge effect too when it comes, like it has now. So water is really the one that we should be focusing on.
Right.
But I don't think we would come to the conclusion that we should get rid of the water in the same way they're saying we should get rid of the CO2. These people who are building billion-dollar things to store CO2.
Yeah, I know.
CO2
It's stunning.
sequestration.
It's stunning.
They really should be put in chains and not allowed to do that. It's so ridiculous.
Yeah, it'd be just as effective to go to door with a pistol, take people's money and burn it in the backyard. It's equally insane. Okay, so
it is about that's a good.
Yeah. It's about as insane. Okay, so let's look underneath this, and this also will tap into something paradoxical about you, I would say. So let me lay this out and and then you tell me what you think about it. Okay, so my sense is that the great climate apocalypse narrative emerged essentially out of the concerns of people like the Club of Rome and the concerns in the 1960s that the human race was that we could be modeled like mold in a petri dish, and that we would expand our population till we consumed all available resources and perish in a cataclysm, and that had to be stopped. And that was the sort of dire situation put forth by the biologist Paul Ehrlich, for example, who's been beating this drum ever since the mid-60s. Okay, so the Club of Rome people got together in the mid-60s, and they decided that there were way too damn many people on the planet. Something radical had to be done about that, which is a bit of a dangerous presumption in my estimation, right? And a bit of an anti-human presumption. But in any case, the consequence of that was the emergence of the more radical side of the environmentalist movement. Now, I hesitate to say just that, and this is where I would really like your input, because there are a number of reasons for wise people to be cautious and concerned about the relationship between human beings and the broader ecological system. So I spent a lot of time analyzing human effects on the so-called environment, and I came to the conclusion that we're misdirecting our apocalyptic attention in a variety of pathological manners. Because, for example, I think that the fact that we've devastated the natural abundance of the coastal waters, and really intensely in the last 100 years, is a much more pressing concern than our production of carbon dioxide. But it's a concern that it is impossible to get people to attend to. Now, it's not the only environmental concern. So you could imagine that there are genuine environmental concerns, and then there's this anti-human screeching about overpopulation, and the combination of those two forces drives the demand for an apocalyptic narrative. And then that feeds into the politicians' venal wish to be seen as the saviors for a problem whose progress towards solving can't be measured, and that also enables them to proclaim themselves as something like the saviors of the natural world, right? So the reason I'm asking you this is because I'm trying to delve into the reasons why the apocalypse narrative surrounding climate got going to begin with. Now, you were there at the onset of the environmental movement, say with the Greenpeace types, and you had your environmental concerns. So what was driving your concern at the onset and the concern of your compatriots, and why did your paths deviate?
So we're
yes,
talking
we
about
tried
cause
to,
now.
you were trying to get me started on that at the beginning, and we got off on too many other things. But yeah, I'd like to explain why I joined Greenpeace and why I left Greenpeace. I think I did say that I was doing a PhD in ecology, and that led me into environmental concerns. And there was hydrogen bombs being detonated by the United States in the Aleutian Islands, and there was still atmospheric testing of nuclear weapons by France in French Polynesia. And that was the first target of Greenpeace's campaign. It was Greenpeace. The peace in Greenpeace is about people. It's not about the environment. Green is about the environment. And so we were, at the beginning, we were actually doing humanitarian work rather than an ecological work in some ways. I mean, we were trying to stop the possibility of an all-out nuclear war by waking people up to the arms race and all of that was going on at the time. And
that was when. That was when. What
1971 was 1971 was the voyage to Amchitka with 12 of us on a small fishing boat, 85-foot boat, crossed the Pacific Ocean, got arrested by the Coast Guard, made Walter Cronkite's Evening News, and had tens of thousands of people marching in the streets. And so there were lots of other people involved, but we were the tip of the spear on that because we got up out of and did something and quit our regular lives and went on a 3-month campaign on an old fish boat and learned a whole lot of stuff and had a great time and because we all had a motto: the revolution should be a celebration, not killing people and stuff. And so we did that. And then the next year, we've had such success. We had defeated the world's most powerful organization, the U.S. Atomic Energy Commission, because they stopped their next test that they were going to do. Nixon did that. And it was very shortly after the bomb we were going against. They did set that one off. I guess they couldn't lose that much face. But they stopped that program. So we said, well, let's head for Mururoa Atoll in French Polynesia and stop the atmospheric tests. And it only took 2 years to do that in a 26-foot sailboat going from New Zealand, while the rest of us went over to Europe. And the first thing we did was we asked for an audience with the Pope, which he gave us and mentioned our name during his speech from up on his porch there. And that was pretty thrilling. And then we went to Paris and occupied Notre Dame Cathedral, just a half a dozen of us, handing out pamphlets because even Le Monde at that time was controlled by the state. No one in France knew about the atmospheric nuclear tests in French Polynesia. It wasn't a subject to be discussed. And so we were handing out these pamphlets, and then we sat in the pews, and as it was time for closure, the Sûreté came in, and we said, we are occupying this church overnight as a demonstration. And they said, excuse me, sir, but this is not a church. It is a national monument. And you will come to jail with us if you don't get out of here right now. So we're actually quite smart about these things. We didn't want to go to jail, and we got out. But we made Le Monde the next morning. For the first time, there'd been a story about the French atmospheric nuclear testing. And then we went to Stockholm, where the first international meeting on the environment took place, where they were talking about all kinds of environmental things, but they sure weren't going to talk about nuclear. That's what the superpowers, as they were called in, the nuclear weapon states, made it very clear that war was not an environmental issue. And so therefore, atmospheric testing wasn't an environmental issue, even though it was sending radiation around the whole southern hemisphere for months of the year. And but we didn't go to the alternative conference. In all of these conferences, there's an alternative hippie conference with colorful flags and dancing girls and all that sort of thing. We went to the real conference because 6 months earlier, Jim Boland and his wife Marie and I, Jim Boland was one of the leaders of the early Greenpeace group. He's an engineer who worked with Buckminster Fuller on the domes up north, the Dewline domes. Really smart guy. Mm-hmm. And I went with him as an ecologist and his wife, and we lobbied every southern hemisphere country, especially the ones on the Pacific, about the situation and that we were going to send a boat and all that stuff. And then we went to the Stockholm conference and convinced the New Zealand delegation, who had been the sort of strongest against this all along. And the New Zealand delegation put a motion on the floor against atmospheric nuclear testing and won by a landslide. So it was a great embarrassment to them all. And the next year they quit. They did do one more year. Yeah, they did. Mm-hmm. But then they went underground, and now they're not doing it at all. And then they sank our boat in New Zealand with bombs on the hull while people were in it. One person died. That was the only time there was a fatality during a Greenpeace campaign. We were very careful at our boat with our boats, because boats can kill people pretty quick if the weather gets bad. And I grew up on a floating village, so there was nothing but boats. And my dad's logging camp in Winter Harbor on the north tip of Vancouver Island, which we still have a family compound there. We're not in the forestry business anymore, but we were for about 100 years. And so I grew up on a tide flat with a dock and a few houses and a couple of rivers and a lot of forest. And so I was naturally interested in nature. So I joined Greenpeace. We went on these voyages. And as time went on, we then moved into more environmental issues, such as toxic waste, pollution, cleaning up the rivers in Europe. North America had already passed good Clean Water and Air Acts earlier than we were in the late 60s. But Europe had not. And almost every big river, the Elbe, the Rhine, the river in London, the Thames, they were pretty much dead. And so we got a smaller boat, the river boat, we called it, about a 50-foot boat, and went up these rivers with divers and plugged the pipes of the factories that were putting poison in the rivers underwater where no one could see it going in. And so we plugged the pipes and it backed up into the factories, and that made the newspapers happy, and we won. And so that was good. And then about the early 80s, a change occurred where environmental groups were now describing the human species as the enemies of the earth.
Right. The cancer on the planet.
Yeah, disaster for life and all of that. So we kind of, the peace got dropped out of the Greenpeace. And, but it's too much like original sin for me to think that humans are the only evil animal on the planet or evil species on the planet. I just don't go for that. I'm not into that. But I stayed for a bit, even though they were saying these things. And
how did that happen? Why do you think that happened? What changed?
We were infiltrated by the political left.
Yeah, okay. So that was a Marxist.
So,
It was a Marxist incursion. Yeah. That makes perfect sense. Yeah, because that kind of puts that anti-capitalist spin on it, right? Yeah.
Then what happened, Jordan, is in an international meeting of which I was one of the directors, and we had maybe 50 people around the table by this time from all kinds of countries. David McTaggart, who was our chairman and had become so in political ways, and I negotiated the founding of Greenpeace International with him in a conflict over the use of the word Greenpeace. The San Francisco office was trying to take it away from us, the founding office. And of course, the US has 20 times the fundraising capacity as Canada. And so it became a civil war within Greenpeace. And our lawyer negotiated with me and David the contract of Greenpeace International, which he would become chairman. And I would be the representative for Canada and a representative for US and a representative for Australia, Germany, Germany, Netherlands, UK. We had 9 or 10 countries, all with offices by this time and good fundraising going on. And so David was one of these people who is scared of chemicals, right? Chemophobia, it's been described as, it's sort of like being scared of the climate. And he decided, with advice from others, that Greenpeace should start a campaign to ban chlorine worldwide with capital letters. And I'm going, you guys, salt is sodium chloride. It is an essential nutrient. It is why Gandhi marched to the sea to make salt, because the Brits were taxing the poor people of India for an essential nutrient that they couldn't afford. And so, come on. But not only that, adding chlorine to drinking water was the biggest advance in the history of public health, and to spas and pools and hot tubs, etc. And 85% of our pharmaceuticals are based on chlorine chemistry, and 25% of them actually have chlorine in them. If you look at your cold medicine, you'll see a little Cl there on a lot of them. And so I said, we can't do that, you guys. We cannot ban chlorine worldwide. If you have a particular chlorinated compound that you think should be banned from industry or whatever, let me know. But I'm gone if you do that. And I was gone, and it was peaceable. It was friendly. But I was gone, and I went home to my Winter Harbor home. And with my brother and brother-in-law, we started a salmon farm just when Norway was taking off with that industry. And I ran a salmon farm for 10 years. And in the end, we couldn't grow them for as cheap as they were being sold, because the market, it's one of those things where the market just flips and suddenly you're in a buyer's market. And in the early days, we were in a seller's market. And it's a beautiful product. And I still eat a lot of salmon, in particular, the steelhead that are being grown in freshwater. They've got some way of making rainbow trout get this big in freshwater. And Diefenbaker Lake is one of the main places where they're growing them. And so is the Columbia River. And it's a fantastic product. And your comment about the sea, did you read the book, The Tragedy of the Commons by Garrett Hardin?
Yes.
Do you know that one?
Yes.
Yeah, it really laid it out very clearly that unless you have, and this is why this whole thing about no borders is as completely ridiculous. You have to have jurisdictions if you're going to stop overfishing and over whatever.
Right.
And the international oceans are the place where this should be figured out somehow. And actually, Canada and the United States and Japan and Russia all have a treaty over crabs and salmon that keeps it from being overfished and gives quotas and all that sort of thing. So it is being practiced in some places. The Atlantic side, though, there's 25 countries out there, and Japan is, they don't care who says what. They own the sea, and they're very, and they're on an island, and you can sort of, it's sort of like England, like Great Britain in that way. And as you know, the French and the English have been fighting over whose fish they are for a long, long time. And the same thing goes on in other parts of the world too. And my grandfather was, and his 3 brothers were salmon fishermen out of Winter Harbor. And my dad married his daughter, and a logger and a fisherman, and that's what we were up there. That was about all there was. There was no road. There was no road to Winter Harbor when I was a child until I was 16. And when the road finally came, a 75-mile gravel road from Port Hardy across the north end of Vancouver Island to the most westerly port, Winter Harbor, on the island, and on the near the very tip of it, we thought, wow, now this place is going to boom. Half the people use the road to get out. That's human nature for you. Because they had to stay there all year, and many of them never got out at all because they couldn't afford to go to town. Because getting to town was a 2-day trip on 2 boats, a taxi, and a big steamer going to Vancouver. The north and south of Vancouver Island weren't joined together by roads until about the 1970s. So the North Island was a whole other place. Cool place to grow up.
So when you started to separate yourself from Greenpeace, you said that the 2 things happened to Greenpeace, if I've got it right. One was the incursion of the Marxist anti-capitalist types and the anti-human types as well, who were proclaiming that human beings were something approximating a cancer on the face of the planet. So it's a real radicalization of the green element. Then there's the incursion of the Marxists. And you also said that there was some, what would you say, neurotic over-concern with chemicals as such, right? So that's something more like it's more like a phobia than a reasoned position.
A new paper just came out that said there are more than 9,000 toxic chemicals in plastic. And they didn't name one of them, but they did find 9,000 of them in there, apparently. And that's the kind of stuff that's coming out. They've been saying that plastic is toxic forever. It is the primary product used in healthcare for blood bags, for vinyl tubing. You can take vinyl is the most interesting plastic because it contains chlorine, polyvinyl chloride. So it's the only one of these polymers, the plastics, that has chlorine in it. And because it has that different chemistry, it's able to absorb nearly anything. You can put anti-germ chemicals into it, and you can use it as flooring and wall covering in hospitals so that the germs can't grow on the floor or the walls. And all the gloves and caps and all kinds of things are made out of plastic in healthcare because it is non-toxic. That's the whole point of it. Did I go into the marine plastic, the Great Pacific Garbage Patch? We haven't talked about that, have we?
No. Well, so it's easy for the environmental movement to be captured in a variety of ways, and that's essentially what seemed to happen in the 1980s. So, how exactly did you separate yourself from the group, and when did you start to become aware that the climate issue was a tempest in a teapot, let's say, or even something antithetical to the truth? And what has been the consequence for you of that discovery?
Well, pretty early on, I realized that CO2 was one of the most essential elements for life on Earth and all of those things. I mean, and between CO2 and water, there's nothing else that comes close to the importance of those 2 molecules. That nitrogen would be the next thing you would think about. And nitrogen is interesting in that life cannot absorb nitrogen directly. It has to go through nitrogen-fixing bacteria and they are in plants, mostly in the roots of plants. And the nitrogen fixers are what gives the nitrogen to life. Nitrogen is a really, really weird element, but nitrogen, NO2, nitrogen dioxide, it would be called. We can't metabolize it. It has to be broken down by microscopic life forms in order for us to be able to live. So I see, after learning all these things, it's just so clear to me that we are not evil in the collective sense. But at the same time, there is this mass confusion issue where people dress up in weird costumes and glue themselves to roads and throw tomato juice at Mona Lisa and all this ridiculous stuff. I mean, it's absolutely ridiculous. But what they want, I'm not quite sure. They keep saying they want the climate to get better, but it is a fact that we are a tropical species, and we would.
They're also well, and the environmentalists also tend to be stridently anti-nuclear, which is extremely strange if their primary concern is actually carbon dioxide. So, that's a real conundrum in my estimation, because that seems like an obvious way forward if that's actually your concern. I mean, you can have an intelligent debate about the relative merits of nuclear, but if you're convinced that carbon dioxide is going to destroy the planet, then nuclear seems a perfectly reasonable alternative. But the Greens also fulminate actively against nuclear plants and are having them closed down in places like California and in Germany, much to the detriment both of the economy and the environment. The Germans turned to burning lignite because they closed their nuclear plants, so they managed to come out of the green energy movement producing more carbon dioxide, more particulate matter, less energy, less reliable energy. They increased their dependence on the fascist regimes that provide fossil fuels like Russia, and they quintupled the price of energy. So that's
nobody said logic would prevail. That's for sure. Because the real problem is that in the beginning, the political side of the movement associated nuclear war and nuclear power.
Right.
And they should have nuclear energy should be in the same category as nuclear medicine, not as nuclear war. Right? Nuclear energy is one of the most wonderful things, and we've had 30 years of stagnation and even reduction. There's still over 100 reactors in North America, and not one person has died from nuclear plant in North America. 3 Mile Island didn't kill anybody. Fukushima didn't kill anybody. It was a comedy of stupidity, that Fukushima thing. That first they built 4 reactors 8 feet above sea level where they knew there had been tsunamis in the past. Second,
that seems like a bad idea.
Yeah, the backup generators for if the plant went down, which they had to at the earthquake, they had to shut all the plants down, but they also lost access to the grid. The power lines went down. So all they had was their backup diesel generators. They started them up, everything worked fine for an hour, but guess where the diesel generators were? In front of the reactors towards the sea on skids. They weren't even nailed down. They didn't have any houses around them. And the gas tanks, the diesel tanks, were connected by a hose, and they were also on their own set of skids. And the tsunami came and just took them up in the mountains somewhere. And that was the end of that. And then one by one, they melted down. And then, even stupider, each of those glass towers, those are the Westinghouse style of reactor. The GE ones are, those are the GE reactor. No, yes, that's right. The Westinghouse one is the one with the dome, like 3 Mile Island. And all that is a protection from the weather. The reactor is down low and surrounded by a concrete structure. So those are just in case there's a leak and they don't want water falling on the reactor or whatever. And but when the melted core produces hydrogen by the dissociation of water, because the cladding around the fuel is a catalyst for water separation. So it makes hydrogen, which goes up into those towers. And as soon as hydrogen gets to 8%, any spark causes a massive explosion. And they let that happen 3 times in a row on 3 separate days, because the prime minister, you see, in the United States, at least, probably Canada too, if there's an accident at a nuclear plant, the head of the plant phones the prime minister or the president and briefs them on what's happening and what he is doing about it. In Japan, you brief them on what's happening and then ask permission if you can do some things. And he said no to the breaching of those towers because he didn't want those the radiation that was in them to get out. 3 Mile Island just it did let it get out. If 3 Mile Island would have blown up too if they had not let the hydrogen out. And there's so little radiation. There's so little radiation, it isn't even consequential. And this whole fear of radiation is just another fear of an invisible thing that you can't see what it's doing. And the rules have been made so strict that it's almost doubled the price of building and maintaining nuclear reactors, which is absolutely unnecessary. Whereas with windmills and solar panels, they're getting massive subsidies. And China's strategy is to build lots of solar panels and windmills for themselves, and then export even more than that and tack another 10% onto them. So theirs are pretty well free. And that's what's going on there. This whole thing about electric vehicles, I mean, I thought it was a free country, but not when it comes to CO2. So we are allowing carbon dioxide, which is actually one of the most important and benign substances in this world, absolutely the most essential element for life, because we are carbon-based life. All life is carbon-based. And there is absolutely no evidence that it is having any effect whatsoever on the temperature. Theoretically, it might have a little bit, but it doesn't show in the record that it has any significant. There's obviously many other things that are far more important in determining the temperature of the Earth, and one of them is the position of the tectonic plates. These cycles that we've seen, the ice ages and such, that the oceans are ocean currents on top and diving below at the poles when it reaches 4 degrees C. I mean, water is also the only liquid that gets lighter as it gets colder. That's why it floats. Any other liquid, the solid would go to the bottom. So if water acted like any other element, any other liquid, the ice would have built up to within about 15 feet of the surface. That's all you'd have. And then life may not have evolved in the oceans under those circumstances.
Let's review, Patrick, because we're going to run out of time, and I want to just make sure that we've covered everything and give you a chance to make a few final comments as well. So we started out by talking about the fact that we have decent records of both climate and atmosphere over about a 500 million year period. And that was about the time when multicellular life evolved. And we can detect atmospheric change and temperature looking at the remnants of life in the sedentary strata, and using the activity of elements that decay in a radioactive and predictable manner. And what we see across that large period of time are three things. We see a planet that's often much warmer than it is now, up to 7 degrees warmer. And that's a planet where life is perhaps even more abundant because of the additional warmth. We see an atmosphere that almost across that entire span has far more carbon dioxide than it does now. And we see very little evidence of a profound relationship between carbon dioxide proportion and temperature. And then in the last, okay, so good, we've got that established. And now over the last 2.5 million years, we're in an ice age, the Pleistocene, and that ice age is characterized by periodic movements forward of the ice and recession. And there's been about 40 of them. And at the moment, we're actually in a period that's not only cold by immense standards, hundreds of millions of years, but relatively cold by the Pleistocene standard, and also characterized by an almost fatal absence of carbon dioxide. So we're close to the point where plants start to get desperate, and we're already at the point where if you give them more carbon dioxide, they actually grow a lot better. And so what we're actually doing by burning fossil fuels is returning to the atmosphere the carbon dioxide that was actually sequestered in the remains of plants, and giving the plants an opportunity to flourish, which is what they're doing in consequence of carbon dioxide production, as we know, because an area the size of the United States has greened in the last 2 decades, and our crops are actually more abundantly productive than they have been.
And then
all of that, all of that is true.
Okay, and then we also pointed to the fact that in the 1960s and then again in the 1980s, an environmental movement that had its utility, because human beings should act as stewards for the planet, got demented first by the overpopulation advocates who were freaking out about, like Paul Ehrlich, about something that just not only was not going to occur, but didn't occur, which was the widespread famine that was predicted in consequence of the population explosion, combined with the incursion of the Marxists into the environmental movement and a kind of phobia about industrial activity and nuclear activity that developed in tandem. And so here we are now, spending untold tens of billions of dollars fighting against an invisible enemy that can't be measured properly, that is actually more likely to be, in the final analysis, our ally.
There's no doubt whatsoever. Right? There's no doubt whatsoever that our emissions of CO2 are the salvation of life on Earth. The next interglacial period, the next glacial maximum, which is expected to be about 70,000 years from now, it would go below 150 if it had continued on the same path it was on. I've got the graph made out very clearly that it might take two more glacial maximums for it to get to the Earth dying. But it would get to the Earth dying. There was no way that was going to be stopped after 150 million years of continuous decline. I'd like to talk just for a minute about the Great Pacific Garbage Patch and the issue of plastic in the oceans. It's nothing but beneficial in the oceans, in the same way that driftwood is beneficial in the oceans. And actually, many species of wood have toxic substances in them to prevent them from rotting. Like cedar, for example, and redwood, they have quite a few toxic substances in them. And they won't build playgrounds with them anymore in case the children bite the wood or whatever they're supposed to do. But the fact is, there's two reasons why driftwood is important in the sea. First, it becomes a habitat or a feeding ground for many, many species of marine life, but especially deep sea barnacles. Gooseneck barnacles. They just grow all over them, and then other things eat those. And so there's nothing wrong with it whatsoever. And of course, they say it turns toxic when it goes in the ocean. And I go, yeah, are you kidding? We wrap all our food in plastic to keep it from becoming contaminated. And then you say when it goes in the ocean, it becomes a toxic hazard? Like, give me a break. It doesn't change its chemistry. It's one of the most inert things in the world. You keep saying it takes 2,000 years to break down, and then you say it's all turned to microplastic and it's getting lodged in the livers and kidneys of fish, which is another lie, because microplastic, of course, is invisible. And no one's ever actually found any. But the other wonderful thing is that the Pacific Garbage Patch is fake. It doesn't exist. Go on the internet and look for images of the Pacific Garbage Patch, and you will see that they are all photoshopped. There's not a single one of them that shows an actual patch of plastic twice the size of Texas, which is what they said. But nobody can see it, so it might as well be invisible, just like polar bears and coral reefs. That's why I titled my book "Fake Invisible Catastrophes and Threats of Doom," because all of these so-called catastrophe stories are based on things that are either invisible or are remote. I call it the universal theory of scare stories. And there's this fantasy in physics that there will be a universal theory of everything someday, like tying all the different forms.
Right.
I doubt that'll happen, but I don't think the world is that unified to be able to do that. But it is true that the universal theory of scare stories is a fact, that they deal with, all of them deal with things that are either invisible or remote, or in the case of GMOs, non-existent. And then the other thing is that seabirds benefit from plastic immensely. All birds have a gizzard, and they don't have teeth, so they have to swallow things whole. Some of them have sharp beaks to tear things apart, but they still have to take big gulps. And if it's something that can't be easily digested in an acid stomach, which they also have, they have two stomachs, one like ours, and another one, though, where land birds and shorebirds put pebbles all their life, they swallow pebbles as the grinding agent in their gizzard. And when the chicks are on the nest, they have to bring pebbles to the chicks. Well, albatross and other seabirds, there's no pebbles out in the ocean there. So they use pumice as their favorite thing, but it's not available all the time because it comes from undersea volcanoes that aren't erupting all the time. But when they find that, they make a cache of it. And the other thing they use is bits of wood that are of the appropriate size and shape. And today, bits of plastic of the appropriate size and shape. And there's one picture of a mother albatross giving, not feeding, that awful man in England who does the BBC scare stories about walruses committing suicide because of plastic or something. I forget what he said it was because. It was because a pack of polar bears were going to eat them, and they decided they'd rather fall off a cliff than be eaten alive by a polar bear. But all over the world, seabirds are using bits of plastic as a substitute for the other rare things that they have to find for their chicks. And then, what's his name? The TV personality on BBC who does the nature shows. Attenborough, yes. He's a fake. And he says, he shows a young woman, as assistant of his, holding up a big clear plastic bag, saying this plastic bag was given to the chick. And when the chick died, we did an autopsy and we found this plastic bag in the chick. It's a total lie. No mother albatross or father albatross would give a plastic bag to its chick. What they give is little pieces of uniformly sized plastics that go into the gizzard and do when they give a whole squid to a baby and themselves, the squid gets ground up and the poop gets pooped out, but the beak stays in there as a grinding agent. So that's one of the ways they get a hard object in there. And it's fascinating, but the Smithsonian goes along with the story that they're feeding plastic to their chicks, and that it's a negative thing. It's been studied for 50 years, and no one's ever found a negative thing about it. It's just a substitute for all the other little hard objects that they've got in their region. And as I say, it's rare to find pebbles on a windswept rocky island, and that's just the way it is. And they should be telling people that it's a great story that our little bits of plastic are useful. And there is no Pacific garbage patch. Only one picture on the internet that I've found. I've looked all over for the Pacific garbage patch on the images in the internet. And there's one that shows a massive area of debris over the ocean and a diver coming up. And underneath it says part of the Great Pacific Garbage Patch. I studied that photo for a little while and realized there's mountains in the background, right in the background. There's no mountains in the middle of the Pacific Ocean. It's the debris from the tsunami that killed 18,000 people. And they're using it to lie about the plastic garbage patch. Because there was 20 towns swept into the ocean and 18,000 people killed. The nuclear plant didn't kill anybody, but CNN had a headline in the middle of that disaster. But it wasn't a disaster from a human life point of view. 2 people did die. They were swept away by the tsunami. But on the headline said, nuclear crisis deepens as bodies wash ashore. That was the headline.
Right.
And I've looked it up and it's gone. I guess they decided it wasn't really a very good thing for people to know about. Because imagine that, blaming the 18,000 bodies on the nuclear disaster. So that's the kind of thing we've got going in this world these days, and I'm doing everything I can to try to straighten it out. And I think you saw my presentation. I cover a wide number of topics, and I do not believe for a minute that these scare stories are true. Like, what is it in the GMO that this is a multi-billion-dollar anti-GMO campaign where the Europeans are refusing to buy crops from Africa if they adopt the improved product, when in fact every single one of us is genetically modified. None of us are identical to our parents. That's what sexual reproduction is. Mixes the genes up. And all they're doing is very methodically taking a gene that they know exactly what it does in the species they're taking it from and putting it into one that doesn't have it. And that's what golden rice is all about. I campaigned for 5 years on golden rice. I came back into the movement in 2013, and my brother and my wife and I got a team of people from Germany and India and Australia, and went to all of the Greenpeace office locations and demonstrated in front of them, and got to 30 million people by the media. But we couldn't do it because they've got control of the environmental apparatus in the governments, in the same way as this whole so-called, what do they call it? No, I forget the name of the movement. What's the name of the movement? Woke. That's right, the woke movement. I probably want to forget the word because it's so stupid, but they're anything but woke, and just have lost all scientific and communicative faculties. They're insane. It's some kind of mental disease, from my way of thinking. And the climate thing is no different than all of these other social and political things. I mean, equity, yeah, sure, that's a good word, but they're using it like a sledgehammer. And because all people aren't the same, and good for that. We don't want all people to be the same. Mm-hmm. And to say that white people are all racist, if that isn't racist, I don't know what is. How can anybody think that way?
Well, this is the mystery that we're trying to unpack with podcasts exactly like this. Yeah. Well, all right, sir. We should stop this. For everybody watching and listening, I'm going to continue to talk to Dr. Patrick Moore for another half an hour on the Daily Wire side. And I think I'm going to talk to him, at least in part, about the consequences of putting himself outside the more radical faction of the environmentalist movement. So that should be a fascinating discussion. And if you want to join us on the Daily Wire side and throw some support their way, they make these podcasts a consequence of their generosity and have helped me a lot to expand the professionalism of the production and to distribute the content to a hypothetically wider audience. Dr. Moore, thank you very much for talking to me today and for walking through all that complex material, for shedding a bit more light on the relationship between the lengthy history of the world, the climate variation that's been part and parcel of that since day one, the composition of the atmosphere, the relationship between the atmosphere and climate, and also the pathologies of, what would you say, the modern politicization of the environmental movement. Much appreciated, sir. And for everybody watching and listening, thank you for your time and attention. The film crew here in Jacksonville, Florida, because that's where I am today, thank you very much for your help. Dr. Moore, we'll take 5 and then we'll reconvene on the Daily Wire side.
Thanks very much,
Dr. Peterson, it's been a pleasure.